Good morning, guys. So আগের দিনের ভিডিওটা তোরা দেখেছিস, যেটা ইলেকট্রোস্ট্যাটিক্স এর ফার্স্ট পার্ট করেছিলাম, যেটাতে আমি ইলেকট্রিক ফিল্ডের ইনিশিয়াল কনসেপ্ট অবধি পড়িয়েছিলাম, কুলম্বস ল অল্প একটু বলেছিলাম। বেশ কিছুজন রিভিউ দিয়েছে, তার মধ্যে আবারও বলছি, ফন্টটা বড় করে লেখা আমি ওটা আজকে ট্রাই করব, পজিটিভলি ট্রাই করব। আমি জানি না কতটা করতে পারবো। 2 নম্বর হচ্ছে, একজন কেন বেশ কয়েকজন বললো, আমি নিজেও দেখলাম মাঝে মাঝে জিনিসটা আউট অফ ফোকাস হয়ে যাচ্ছে। এটা সত্যি কথা, আমার কিছু করার নেই, কারণ এখানে ঘরে আর কেউ নেই যে ফোকাসটা সবসময় ঠিকঠাক করবে। আমি এটাকে জাস্ট একটা ট্রাইপড টাইপের জিনিসের উপর রেখে, গরিলা বোর্ডের উপর রেখে ভিডিওটা করছি, আর আমার মোবাইলটাতে ফোকাস লক করা যায় না। সো ওটা অটোমেটিক্যালি আমি যখন ঢুকছি স্ক্রিনে, কখনো আমাকে ফোকাস করছে, কখনো পেছনটা ফোকাস করছে, ওটুকু সমস্যা হবে। ঠিক আছে, একটু অ্যাডজাস্ট করে নে। ক্লাসগুলোর ব্যাপারে বা যেগুলো পড়াচ্ছি সেগুলোর ব্যাপারে একটা কথা বলার, সেটা হচ্ছে এটা কিন্তু জয়েন্টের উপর বেস করে আমি করাচ্ছি না। ঠিক আছে, আমি মেইনলি চেষ্টা করছি টু কমপ্লিট দ্য বোর্ড সিলেবাস। কমপ্লিট নয়, কমপ্লিট তো কখনোই এরকম ভাবে করা যাবে বলে মনে হয় না। এন্ড হোপফুলি অনেক আগেই লকডাউন মিটে যাবে, করোনার প্রবলেম মিটে যাবে। তো আমি যেটা ট্রাই করছি, যতটা পারা যায় সিলেবাসটাকে এগোনো যাক। জয়েন্টের জন্য আরো অনেক প্রচুর ভালো ভালো ভিডিও আছে, তোরা আমার থেকেও বেশি জানিস। There is even academy, there is physics wala Alak Pandey. I like that guy very much. ওর পড়ানোর স্টাইলটা খুব সুন্দর, ফলো করতেই পারিস। তো যাই হোক, কিন্তু আমার মনে হয় তুই এই ভিডিওগুলো দেখলে ইনিশিয়ালি চ্যাপ্টারটার বেসিক আইডিয়াস, ইউ উইল গেট দ্য বেসিক আইডিয়াস অ্যাবাউট দ্য চ্যাপ্টার, and then you can continue with some higher stuffs, higher videos, maybe higher books. সেগুলো এখানে আমি কিন্তু সেরকম ভাবে জিনিসটা প্রিপেয়ার করাচ্ছি। যাই হোক, so let's continue with electric field. So আগের দিন আমরা এটা করেছিলাম, ইলেকট্রিক ফিল্ডের আমাদের কাছে দুটো ফর্মুলা ছিল। One is E equal to F by Q naught, where this was effect charge formula or field charge formula. আমি বলেছিলাম ইয়ে করতে যে why limit Q naught tends to 0 is given there. আমি জানি না কারা প্রিপেয়ার করেছিস, আমি আবার বলছি, প্রপারলি কিন্তু প্রিপেয়ার করা শুরু করে দে, টাইম কিন্তু একেবারেই নেই। Okay, sorry. And there was another formula, E equal to 1 by 4 pi epsilon naught Q by R square R cap. জেনারেলি অঙ্ক বা থিওরি সলিউশন করার সময় এই ভেক্টর আর ক্যাপ এগুলো খুব লাগে না, ওগুলো যখন লাগে আমি তখন বলে দেবো। ঠিক আছে, তো আমরা জেনারেলি মড নিয়ে কাজ করছি। আগের দিন আমি তোদের দেখিয়েছিলাম হাউ টু ডিল উইথ field of discrete charges. So আচ্ছা, আমি আরেকটা এক্সাম্পল দেখাতে চাইছি যাতে সবার কাছে জিনিসটা ক্লিয়ার হয়ে যায়। দেখে নে, সে আচ্ছা, মেটেরিয়াল মনে হয় সবাই পেয়ে গেছিস। মেটেরিয়ালটা আমার হাতের কাছে এখনই নেই, এরপরে কিন্তু মেটেরিয়াল থেকে আমি অঙ্ক ধরে ধরে বলবো। দাঁড়া এক মিনিট। মেটেরিয়ালটা আমার কাছে এক্ষুনি নেই, যাই হোক আমি একটা ইয়ে বলছি, বাকিরা কিন্তু মেটেরিয়ালটা হাতের কাছে রাখিস। মেটেরিয়ালের অঙ্ক ধরে আমি কিন্তু নাম্বার ওয়াইজ বলে যাবো। ঠিক আছে, সে তোর কাছে এখানে একটা 2q চার্জ, এখানে একটা -q চার্জ আছে। These 3 points are on the vertices of an equilateral triangle of side A. Now you are asked to find electric field at this point. So this is, say this is A, say this is B, and say this is C. What you are supposed to do? We have our superposition formula that আগে দিন আমি মানে অ্যাপ্লাই করেছি। হয়তো আমি ফর্মুলাটা স্টেটমেন্টটা বলিনি, এমন কিছু ব্যাপার নয়। ফর্মুলাটা হচ্ছে ভেক্টর E net is E1 plus E2 plus dot dot dot. This is superposition formula কি একটা জায়গায় net electric field হচ্ছে the sum of the vector sum of all the electric field due to all the charges at that particular point. অনেকের মনে হতে পারে this is trivial, but এটা কিন্তু সবসময় অতটা trivial নয়। যেমন আমরা আরো বেশ কিছু কোয়ান্টিটিস হয় যেগুলোতে কিন্তু আরো কিছু কমপ্লিকেটেড টার্মস ঢোকে, ঠিক আছে? তো যেমন আমি বলছি, ধর তোর একটা, এটা 11 এ তোরা করেছিস, ধর একটা জায়গা থেকে লাইট বের হচ্ছে অফ ইন্টেন্সিটি I1, আর একটা জায়গা থেকে লাইট বের হচ্ছে অফ ইন্টেন্সিটি I2। লাইট দিয়ে পড়িসনি, যারা 11 পড়েছে তারা কিন্তু সাউন্ড দিয়ে পড়েছে। তাহলে ডু ইউ রিমেম্বার, তোকে যদি কোনো একটা পার্টিকুলার পয়েন্টে রেজাল্টেন্ট ইন্টেন্সিটি বের করতে হয়, সেটা কিন্তু সিম্পল স্কেলার সাম হয় না, ঠিক আছে? সেটা কিন্তু খুব কমপ্লিকেটেড একটা সাম হয়। I equal to root over I equal to I1 plus I2 plus root over 2I1 I2 cos phi whatever। কিন্তু মোদ্দা কথা, ইলেকট্রিক ফিল্ডে কিন্তু এই ভেক্টরের সুপারপজিশন ফর্মুলা অ্যাক্ট করে। সো একটা পার্টিকুলার পয়েন্টে ইলেকট্রিক ফিল্ড বের করতে গেলে ইউ ফাইন্ড আউট ইলেকট্রিক ফিল্ড ডিউ টু অল দ্য চার্জেস এন্ড ইউ অ্যাড देम ভেক্টোরিয়ালি। সো চেক ইট আউট। এই পয়েন্টে এ পয়েন্টার জন্য ইলেকট্রিক ফিল্ড কোন দিকে হবে? হোয়াট ইজ আওয়ার ডাইরেকশন? আগের দিনই বলেছিলাম পজিটিভ চার্জ থেকে রেডিয়ালি আউটওয়ার্ড যায়, নেগেটিভ চার্জে টুয়ার্ডস আসে। সো এটা পজিটিভ চার্জ, পয়েন্ট চার্জ কিন্তু মাথায় রাখতে হবে, পয়েন্ট চার্জ না হলে ফর্মুলা অ্যাপ্লাই হয় না। সো দিস ইজ EA as per our convention used in last class, EA, and this is negative, so this is EB। যদি ভালো করে দেখিস বুঝতে পারবি আমি কিন্তু দুটো ভেক্টরের এই ভেক্টরটাকে বড় এঁকেছি, কারণ বুঝতেই পারছিস these two distances are same, but the source charge being higher, electric field due to A will be more than electric field due to B. Okay, so we are supposed to find EA. What is the magnitude of EA? This is, you have that formula, 1 by 4 pi epsilon naught. It is 2q by, this is distance squared, a squared, in this direction. Okay, and if we got the, this is 1 by 4 pi epsilon naught q by a square. It again into magnitude. So what is the net field? How to calculate that? You need to find out the vector sum. So obviously এখানে তোকে i cap j cap কিন্তু বের করতেই হবে, i cap j cap কিন্তু করতেই হবে। হ্যাঁ, তুই বলতেই পারিস আমি i cap j cap করব না, অন্য একটা ভাবেও হয়, বাট আমি তোকে দুটো ভাবেই দেখাচ্ছি। ফার্স্টে i cap j cap শেখাটা ইজ আ মাস্ট। Say this is i cap, say this is j cap. So check out this vector, EA vector makes angle, this is 60 degrees, so this is corresponding 60 degree. So here it is, this is basically EA cos 60, and this is basically EA sin 60. Again, I am telling you, if you have any problem in your vector understanding, then it will be tough for you to comprehend these topics. So those who are having some difficulties, please go through the vector chapter. Vector is very essential to understand these topics. So this is EA cos 60, this is EA sin 60. And what is the EB part? Here it is EB component in this direction. So this is EB. What is the angle? Okay, this is 60. So this is again 60. So this is also EB cos 60, and this is EB sin 60. Done. Okay. This is 4 pi epsilon naught. So you need to just add them. Here you need to subtract. So E net, check out. E net is EA cos 60 plus EB cos 60. This is in which direction? I cap. Plus this is EA sin 60 j cap. This is EB sin 60 minus j cap, right? So all in all, this is EA sin 60 minus EB sin 60 j cap. Hope you understand this point. Then look, EA means there is 1 by 4 pi epsilon naught q by a square. So let's 1 q by 4 pi epsilon naught square, that is common. So let's that take outside. So q by 4 pi epsilon naught a square. This goes outside. There is also cos 60. So this is also outside. Okay. Let me know in your comments if I make any mistake during calculation. Okay, you know I do a lot of calculation mistakes, so let me know if I do something wrong. এই অঙ্কগুলো কিন্তু আমি একদম মানে জাস্ট মন থেকেই বলছি, সো অ্যানসার আমি জানিও না বেশিরভাগ ক্ষেত্রে, মানে জাস্ট অ্যাপ্রোড দিচ্ছি। সো যাই হোক, q by 4 pi epsilon naught a square চলে গেছে 60. So this is what is remaining with us. For EA there is a 2, this is 1. Okay, done. So this is I cap plus what is this again, let us say common, q by 4 pi epsilon naught a squared, common galo. This is, oh sorry, sin 60 is there. So sin 60, here is 2 minus 1, and this is j cap. Do you agree? আবার দেখলাম লেখাটা ছোট হয়ে যাচ্ছে, আই এম সরি। নেক্সট q by 4 pi epsilon naught a square, cos 60 means half 3 I cap plus q by 4 pi epsilon naught a square, sin 60, that is root 3 by 2, 2 minus 1, 1, that is j. Okay, so this is your answer. If you want to find the magnitude of E net will be basically square root of ex squared plus ey squared. Don't put this all everything in under square root. Don't square them and square root them. You can do the calculation. Sorry, cancel. In a jiffy. Just take common. Okay, first take what is in common. This is q by 4 pi epsilon naught 2 times 4 pi epsilon naught a square. You can take root 3 outside, but that is not needed. This is common. So what will happen if you square them and then add them? Then it will be in common, and when it comes outside the root, it will be again a divide of the square. So this goes outside, and what is remaining? So this is 3 square plus root 3 square. Okay, so this is q by 8 pi epsilon naught a square times this is 9 plus 3, 12, root 12. Root 12 means 4 times of 2 root 3. So the answer is root 3q by 4 pi epsilon naught a square. Okay, and if you want to find the direction, that can also be calculated. I've shown you in the last class. Tan theta will be a y component by x component, and you are done. So okay, how to calculate it? What is the another process? The other process is you don't take this I caps and j caps. You don't take those I caps and j caps. Which one? What do? Look, you have two vectors. You know the angle between them. That is 120 degree. So you just calculate E net equal to root over EA square plus EB square plus 2 EA EB cos 120, because the angle between the vectors is 120. You can apply this formula. Okay. What is the result? Let's see. This is okay. E s square. So 1 by 4 pi epsilon naught 2q by s square plus 1 by 4 pi epsilon naught q by s squared plus 2 into 2q by 4 pi epsilon naught s square times q by 4 pi epsilon naught s square into cos 120 means minus half, right? Into minus half. Okay. So take the common part outside. What comes here? So q square q by 4 pi epsilon naught s square, that goes out. What is remaining there? This is q. What is remaining there? There is 2 square plus this is basically 1 square minus this 2 to cancel minus 2, right? Because q square means q outside the root, there will be root here, and 4 pi epsilon naught square, 4 pi epsilon naught square, there is root, and then okay. So is the answer matching, or did I do something wrong? I mean, 2 square 4 5 minus 2 is 2, so q root 3. I think it is okay. This was the last answer. So, I'm telling you, this may look easier, but most of the time people make some calculation mistakes here. Okay, so you can take any roots. Now the problem is here there is only 2 source charges. There will be the situation where there will be multiple charges like 3 or 4. Generally, they don't give more than that. So if there are 3 or 4 charges, then you must do I cap J cap process, because in that case this will be very tedious. Doing vector addition of 1 and 2, then vector addition of 3 with the previous result. This is very tedious. So I would highly appreciate you people if you learn this particular method. This will be very helpful. This is not wrong, but most of the time it is bit tedious, and percentage chance of doing mistake is more here. Okay. Are you having fun? I mean, physics is about fun, trust me. If you don't have fun, you cannot learn, or you cannot properly learn physics. There is another point about electrostatics. Electrostatics is not only about attending the class or studying the class notes or studying the books. It's about visualization. I had a student in our he was topper in techno Chinsura techno Hooghly. So he got 100 in his boards, CBSE. So he got 100 out of 100 in physics. He was very casual. He was a bit lazy. He was a bit casual. In fact, not bit, quite casual. He used to play some musical instruments. Okay, but he was very he was as far as I can remember, he was KVPI scholar, KVPI or either KVPI scholar or he was eliminated in India due out. I cannot remember right now, but whatever. When he came to me in class 12, in class 11 he was not my student. In class 11, the very first day of class 11 he came to me, but actually we had our date didn't match. Date match করেনি বলে ও পড়তে পারেনি. So when he came to me in his class 12, I asked him, why are you coming to me? You learn from another teacher and I think he is quite good. He said, actually I cannot visualize the electrostatics problems. মানে ও প্রথমে নিজে নিজে কিছু electrostatics পড়েছিল বা যাই হোক, and he was unable to visualize the sums, visualize the situation. So electrostatics is, I am telling you again, all about visualization. Initially this electric field will not give you that impression ki, why do I need visualization? Electrostatics is okay, there is field, so I know vector, it will be fine. No, when you start Gauss, when you start flux, you need to visualize the concept, you need to visualize the situation. If you cannot visualize, you cannot go beyond a particular level. So from now on, try to see the things. What is happening? There is a charge. Here is another charge. These two are repelling or attracting. So what will happen if they repel? What will happen if they attract? Say, if they attract, they will come closer. Now, when they are coming closer, the force, say they are being attracted. So if they come closer, what is happening? The distance is decreasing. So the force is increasing. So this is a force is increasing means the acceleration is not uniform. So I cannot apply s is equal to ut plus half d square or d square equal to u square plus 2s. You need to think like this. If you don't think like this, you will get trapped. You will apply wrong formulas. I will give you all the study materials, all the notes are there. There is a gist of formulas. That is not useful. Study material is not useful to understand the subject. You need to visualize it. I am telling you. There will be lots of people who will give you some formula, give you some notes. They will show you from that study note that, look, this is a sum. You apply this formula, you apply it again. You have applied 3 formulas and your sum is done. Wow, how beautiful it is. No, that is not electrostatics. To learn electrostatics, you need to visualize the system. You need to discuss it with yourself. Okay? So whatever, I have this. Now I am going for continuous charge distribution. Continuous charge distribution. What do you mean by continuous charge distribution? The charge, there is no basically discrete charge. Charges spread out in continuous manner on maybe a rod, on a circular ring, on a disc, whatever. There are lots of formula given in your study material. You need to study them. For boards, you do not need to prove all those formulas. I am just showing 2 examples how to calculate continuous charge distribution, and to understand this particular topic, if you remember calculating moment of inertia or center of mass from your class 11 syllabus, then this part will be really easy. The procedure is almost same. So say here is a stick. Its length is L, and from this end, this is left end, from the right end, at a distance of D, there is a charge, there is a point P. Q charge is distributed uniformly over this stick. uniformly. So this is positive charge. So you are supposed to find electric field at this point. If you find electric field, then you can also find what will happen if another point charge is kept here. You can apply F equal to EQ. Here this is the source charge and you are supposed to find out. But the problem is you cannot apply Coulomb's law or the formula for E equal to 1 by 4 pi epsilon naught Q by R square directly here, because there is no point charge. That formula is applicable only for point charge. So what do you do here? You have to integrate basically. Everyone got that conception. Your people are class 12 people. So you take your x equal to 0 here. Say this is x equal to x, any arbitrary length on the rod, and say this is a very small length of the rod dx after x. Now in class 12 there will be lots of area where you need to apply the concepts of calculus, specifically the integration part. So learn the integration process clearly, and learning or memorizing only the formulas of integration will not help you. You need to know how to construct the integration. What is dx, what is x, how a small part is giving some effect here, and how to integrate it. This will be the main topic. So এই ধরনের প্রবলেমে আমরা ইনিশিয়ালি সব সময় একটা ছোট্ট পার্ট অফ দা কন্টিনিউয়াস চার্জ সলিউশন নিয়ে নেব. This is the small part, and we will consider this to be almost a point charge. This is almost a point charge because it does not have, the dimension of it is very small compared to the whole length of the rod on all the corresponding distances. So this is, we are considering this to be a point charge. So what is the charge on this point segment? For that you need to calculate linear charge density. What is linear charge density? Linear charge density lambda is basically charge per unit length. Now as Q charge is spread uniformly over this length, so the charge per unit length must be Q by L, and this is your linear charge density. There may be situations where lambda will depend on x. In some comparatively tougher maths, lambda will depend on x, and that one will given to you. Okay, so like say lambda equal to kx. That means here at x equal to 0 there is no charge, and with increasing x, k is a constant, so with increasing x there will be stronger and stronger charge here. So there will be different field. It is like exactly like that center of mass or moment of inertia calculations. For continuous mass, there was continuous mass distribution. Here it is continuous charge distribution. So lambda equal to Q by L. So what is the charge in this small segment? This has got the length dx. So one length contains charge lambda. So dx length must contain charge, and that will be called dq equal to lambda dx. This is true everywhere. dq equal to lambda dx. This is almost a universal formula. So what is the field at P due to this point charge? Now this is a source charge problem. You know the Q, which is basically dq. So we call it dE. I am not giving the vector sign. dE equal to 1 by 4 pi epsilon naught, not q but dq, times distance squared. I mean by distance squared. What is distance? Distance means the distance from the point charge to the point where field is to be taken. So this is the distance. What is this distance? See, this is d, this is x, this is L. So this distance is L plus d, and this is x. So L plus d minus x. This is this distance. Are you clear about that? You are supposed to write distances square here. What is r here? R means this distance from the source charge to the point where you are supposed to find the field. So r is basically L plus d minus x. So this is L plus D minus x whole square. Now there is a very important point. If you take some more dx's here, all of them will provide dE here. Obviously, as the x's are different, therefore the value of u will be different from them if you integrate them. Can this integration be done as like scalar? Yes, only because this d is a basically vector, but what's the direction of this d? In this direction. And if you take any small part, all of them will have electric field in the same direction. And therefore, if there are multiple vectors which are acting in the same line, same direction, you know that they can be added like a scalar. That is, if vector 4 and vector 3 acts in same direction, then their sum is, vector sum is 4 plus 3, which is 7. So here again it can be added like simple scalar. So on doing the E is basically integration 1 by 4 pi epsilon naught dq by L plus D minus x whole square, right? What should be the limit? The limit should start from x equal to 0 and not up to x equal to d plus L or R, whatever. The limit should be put, starting point should be the starting point of the rod and end point should be the end point of the rod, because charge is distributed only up to that point. This portion do not give any effect on this point. So therefore the limit will be from x equal to 0 to x equal to what is it? Oh, okay, L. So if you can integrate this one, you can find out the answer. This integration is rather easy. You need to apply substitution. L plus D minus x equal to dp. Sorry, minus x. This is dp. So minus dx equal to dp. So integration L plus, this becomes, okay, sorry. For this dq, you can write down what this lambda dx. Lambda dx. Lambda is a constant here, so it will come outside the integration. So this is dx by this square. So dx is minus dp L plus d. This is p. This is p square. Okay. So this is minus dp by p square means p to the power minus 2 into it minus. So this is 1 by p. You agree? Am I correct? P to the power minus 2 plus 1 minus 1 way. Okay. So this is lambda by 4 pi epsilon naught. This is constant, goes out of integration, and the remaining part gives you 1 by p. So this is 1 by L plus D minus x. The limit extends from 0 to L. So this is lambda by 4 pi epsilon naught 1 by L plus D minus L. So still D minus 1 by L plus D. Looks nice. So this is lambda by 4 pi epsilon naught. This is D L plus D times L plus D minus D. So this is L. And check out, lambda L equal to Q. So the answer is Q by 4 pi epsilon naught D L plus T. Okay, and another thing, if you take this point very far away from the rod, then L plus D is almost D. So this is D square. I am not suffering from corona, I guess. আজকাল যাই হচ্ছে মানে হাসি হাসি ভালো হচ্ছে যাই হোক এটাকে অনেক যদি দূরে নিয়ে যাওয়া হয় then L plus D will be almost equal to D. L plus D will almost equal to D, and তার মানে একটা রড থেকে অনেক দূরের কোন পয়েন্টে if you are finding field at a point very far from the rod behaves like a point charge, but that should be very far. Whatever, your answer is this one. Okay, I am giving you a home task. Just pause the video and try to do it now. Do this same sum, but this time take x equal to 0 here. Okay, take x equal to 0 here and change the integration, change the things accordingly. This will be D, this will be d plus l, take dx and do the sum. So that there will be this will be x, there will be dx. Do this sum, pause the video, do this sum and see if the result matches. If you can do it, you have learned it properly. Taking origin at this point will make integration tad bit easier, that very easy for you people to comprehend. So this is how to calculate field for continuous charge distribution. Another thing, choosing x equal to 0 intuitively can not always, can make integration or some part comparatively easier. So you need to check out lots of problem like this, see if there is any problem. Okay. Okay. There is another type of problems in continuous field distribution, and that is like, it is a semicircle of radius r, and again q charge is distributed over it uniformly. So what is the lambda here? This is q by the length of the rod is pi r. Okay. You are supposed to find electric field at the center. So how to do such problems? What would be the electric field if it is a perfect circle? 0. Why 0? Because if this is a perfect circle, if you take your dx here, this dx will produce a dE in this direction, whereas this dx will produce a dE in this direction, and these two d's will get cancelled, and this will be true for all the charges. This is a symmetric charge distribution, so electric field at the midpoint will be 0. But if it is a half circle, then those cancellation do not occur. So how to calculate that one? What is the major problem? Can we calculate it like previous sum? No. Why no? Because if you take dx or dl, whatever, dx here, this dx will have charge dq, and that dq will produce a field dE in this direction. What is the value of dE? It looks nice, 1 by 4 pi epsilon naught dq by, what is this distance? This is r, which is a constant. So you may think that, sir, this is easy. We will write 1 by 4 pi epsilon naught. This is lambda dx, 1 by r square. We will integrate. So lambda dx, lambda will come outside. This r square will come outside, and integration dx is x. X means the whole length of the semicircle. No, because again you need to visualize. If you take another dx here, it will produce field, but only in another direction. So just like the previous case, you cannot add them just like scalars. Here you need to apply the concept of vector addition. So what we are supposed to do? এই ধরনের সামে one thing you need to do first, what should be the variable? Is the variable dx is enough? No, because direction change is not contributed by dx. So which part gives you contribute towards the direction change? Obviously this angle theta, and we will integrate it over theta. How? That what I am showing. Look, if this is theta, then this is also theta, and here dE will have two components. Okay, dE cos theta, and here it is dE sin theta.
So sir, do we need to calculate d cos theta once and d sin theta once? No, there is another very beautiful catch. You take another dx symmetrically placed, that this angle is also theta in the upper quadrant, upper part. This will produce a dE here, and this dE will have component dE cos theta in this direction, but dE sin theta in the downward direction. And you can see that this d sin theta, this d sin theta gets cancelled. So from here to here, from 0 to minus pi by 2, you can take any theta, and for that you will have another corresponding counterpart of theta from 0 to plus pi by 2, where those two parts, those two small parts will pair up to cancel their sin theta components. And so therefore there will be no component of field along this direction, as this is a symmetric figure about the x-axis. So you just need to integrate not both dE cos theta and d sin theta, but only dE cos theta, and therefore dE net is integration not of dE but dE, আমি বড় করে লিখি, মাঝে মাঝে মনে পড়ে যাচ্ছে, বুঝলি তো, যে আমাকে বড় করে লিখতে হবে, dE cos theta. So what is the form of the integration? This is 1 by 4 pi epsilon naught dq means lambda dx. That's what you know. Just always remember dq is lambda dx. So what is x here? Lambda del square cos theta. So you cannot integrate it because there are two variables. One is dx and another is cos theta. So how do you integrate it? This is easy. Again, you need to visualize what is your x. This time x is not a straight line but a curved part. This is your x because you take dx after x. This is your baseline or reference line. So this is dx. So what is the relation between x and theta? X equal to r theta. Agreed? So as x equal to r theta, what is dx? This is r d theta. R is constant. So you put it here. 1 by 4 pi epsilon naught lambda dx means r d theta divided by r square times cos theta. So sorry, that is the integration. One r gets cancelled, they are constant. So lambda by 4 pi epsilon naught r, sorry, r is below the division sign. The integration is left with only cos theta d theta. This looks nice. And what is the limit? Now check. You can do this integration, you can put this limit in two ways. One is, if you take d cos theta here, then you have to cover all the semicircle. So this is minus pi by 2 to plus pi by 2. The process I have followed. But if you take 2d cos theta here, if you take, I have not taken that, 2d cos, you can take it. If you take 2d cos theta, what you are basically doing? You are taking the contribution from both the parts. So in that case, you need to integrate from minus pi by 2 0 only. Automatically, due to your 2, the upper part, whenever you are taking this contribution, that 2 means you are taking also the contribution of the upper part. So integrating up to this point is enough. It will automatically integrate this point. That's 2 will be enough for that. So you can do anyone. So this is lambda by 4 pi epsilon naught r times cos theta integration. Cos theta means sin theta. So this is sin pi by 2 minus sin minus pi by 2, which is 1 minus of minus 1, 1 plus 1, 2. So this is lambda 2 lambda by 4 pi epsilon naught r. You should put the value of lambda. So 2 by 4 pi. I generally don't cancel 4 pi epsilon naught. You can do that. Times lambda means q by pi r. So the answer is 2q by 4 pi square epsilon naught r square. Okay, thank you. You continue with it. You will get the sums You already have the sums. I have sent you the question paper. I will give you the number of the sums that can be tried by you just up to learning this point. This is very important. In next class I will discuss about potential. Okay, potential, electrostatic energy, electrostatic potential energy, and after that I will start Gauss. Dipole I will teach that after that. Okay, thank you.